Hi everyone, Miss Barber here for a little bit more regarding lessons 2.1, 12.1, 12.2, 12.3, and 12.7 in geometry on transformations. So in the first video, you saw what these different types of transformations, reflections, rotations, translations, which are isometries, rigid motions. They don't change the size of the shape, they just change its location on the paper. And then the last one was a dilation, which makes something bigger or smaller. Well, these are now the rules in order to complete these transformations on a coordinate plane. So remember, the pre-image is the image or the shape before you transform it, and we will just call the shape as it is. So a lot of times we deal with triangles. So for example, it would be triangle ABC. Then the image is after the transformation is performed, and we usually denote images with apostrophes. So you might call it A apostrophe, B apostrophe, C apostrophe. So let's talk about the first transformation you learned, which was a translation, which is sliding a figure to a new location. So the rules could either be written where you're taking your values for X and Y and adding an A onto X and a B onto Y. So that's how you move something left and right for positive and negative A, and up and down for positive and negative B. Another way that you'll see it written is as a vector. So the vector would be written as, instead of AB, like that, it would be as AB, the vector. Again, a positive A moves something right, a negative A moves something left, a positive B moves something up, a negative B moves something down. So you would just add your A to your X and your B to the Y. And again, it doesn't matter if it's written in vector form or in this T to the A comma B. The second rule that we need to make sure we know is reflections. So reflections when you flip something over a given line. And there's 4 different ways we can reflect. If we're reflecting over the x-axis, what happens is you change the sign of y. So it's written as negative y, but it doesn't mean that y has to be negative. It means if it was negative, it becomes positive. If it was positive, it becomes negative. The x stays the same. If you reflect over the y-axis, your x changes sign. Again, your x, if it's positive, becomes negative, negative, positive. Your y will stay the same. For the line, reflecting over the line y equals x, your x and your y just switch places. So your x and y are just going to switch. And then if you're reflecting over the line y equals negative x, they're going to switch and change sign. So again, if they're negative, they become positive. Positive, they become negative for switch and change sign. So that's for reflections. Next one is rotations. So rotation is when you turn something about a point. It's really important to remember for our rotations, it's always going to be counterclockwise. So look at how a clock moves. We're going the opposite direction. So counterclockwise is like the arrow I just drew. So in order to move in something 90 degrees counterclockwise, rotate it 90 degrees counterclockwise, you'll see that the x and y change place and the original x changes signs. So x and y change place and whatever was x before changes signs. To rotate something this first one says 90 degrees clockwise. Why don't you go ahead and change that? That's the same thing as 270 counterclockwise. How about you write that instead? Because we're going to talk about everything going counterclockwise. So 90 degrees clockwise is the same thing as 270 counterclockwise. So again, 270 counterclockwise, you change x and y and make your original x negative. For the second one, rotating 90 degrees counterclockwise, you switch x and y, but then whatever was your original y becomes negative. And then rotating 180, it doesn't matter if it's clockwise or counterclockwise because that's the same. You just change the signs, but nothing gets moved around. So just change the signs. So that's for rotations. And then finally, the last one we have, is dilation. So dilation is the only thing that makes something bigger or smaller. If k is greater than 1, that's enlarging. If k is less than 1 but greater than 0, it's going to be a reduction. You also might encounter a negative dilation. A negative dilation is a combination of a dilation and a 180-degree rotation. So the rule for a dilation is whatever that scale factor is, k, you just multiply k to both the x and the y. And again, if there's a negative k, we'll also combine a 180-degree rotation because it's going to change the signs of your x and your y, which is the same thing as a 180 rotation. All right, so now let's use these rules to do a few problems from your homework. So let's work on some of your assignment. So starting with the first thing we did, which was a translation, let's do number 9. So number 9, let's just graph what they told me first. So they wanted me to graph L, which is 3, 2, M, which is 1, negative 3, and N, which is negative 2, negative 2. Now, in order to translate it, we're going to take all of my x values and add negative 2. That's what this vector means. So we're going to add negative 2 to every number. Well, 3 plus negative 2 would be 1. 1 plus negative 2 would be negative 1. And 2 plus negative 2 would be negative 4. So that's for your x values. Now let's do the y values. So now my y values, I'm going to be adding 3 to all of my y's, which means going up 3. So 2 plus 3 is 5. Negative 3 plus 3 is 0, and negative 2 plus 3 is 1. So now we can graph all 3 of these points, and remember we use apostrophes to indicate that this is going to be the image of my triangle LMN pre-image. So 1, 5 is my new L, so L prime or L apostrophe. M is negative 1, 0, so M prime. And then my new N, which we'll call N prime or N apostrophe, is negative 4, 1. So that's a translation. Everything just moved to the left 2, that's from the negative 2 on my vector, and up 3. So that's how you translate. Next is reflections. So under the 2.1, let's do number 8. Number 8 wants me to reflect across the y-axis. So if you look at your cheat sheet that I gave you, for a reflection over the y-axis, your xy becomes negative xy. Meaning you're just going to change the sign of all of your x values. If they were positive, make them negative, negative, make them positive. So first I'm just going to graph ABC. So A is 4, 4. B is 3, negative 1. C is 1, negative 2. Now, my new points, again, every x value is going to change sign. So 4 is going to become negative 4. 3 is going to become negative 3. C is going to become negative 1. So my new points, my A prime is going to be negative 4, 4. So I can graph that. B prime is going to become negative 3, negative 1. Again, your y stays the same. And my C prime is going to become negative 1, negative 2. So you can see my red, my image, is a reflection over the y-axis. Here's the y-axis of my pre-image. So that is an example of a reflection. Next one is rotation, which I think is always the hardest one. Remember, rotations are always going to be 90 degrees or counterclockwise. It's always be counterclockwise. So let's look at number 7. So they want us to do 90 degrees, and again, it's always assumed counterclockwise. So if you look at your rule for 90 degrees counterclockwise, your xy is going to become negative yx. Meaning you're going to flip your x and y, and you're going to change the sign of your original y. So for my new A prime, it was negative 2, 3. You flip them, and whatever your y was before, which in this case was 3, is going to change signs. So it's going to become negative 3, and your x stays the same as negative 2. B prime would therefore be negative 4, so my opposite of y, comma 3, my x. And C prime is going to become opposite of y, so negative 1, comma, your x stays the same. So I'll go ahead and graph both so you can see what a 90-degree rotation looks like. So A is negative 2, positive 3. B is 3, 4. Oops, sorry, this would be the point. And C would be 0, 1. So rotating at 90 degrees, it would now be negative 3, negative 2, A prime, negative 4, positive 3, B prime, and C prime would be negative 1, 0. So it's really important that you write the coordinate points down, because it can be quite challenging, especially for rotations, to get it right just by looking at the image. Last one that we're going to be working on is dilations. Oops. Dilations, you just multiply by the scale factor. So let's do number 11, because this scale factor is kind of funny because it's a negative. As I said, a negative scale factor not only would, in this case, enlarge my image, it also reflects it across or rotates at 180 degrees. So what you're going to have to do is multiply every point by negative 2. Well, 0 times negative 2 is 0. 0 times negative 2 is 0. So my new point, D prime, would just be 0, 0. Multiplying it by negative 2 doesn't affect it. E prime is going to be negative 1 times negative 2, which is positive 2. 0 times negative 2 is just 2. And then F prime would be positive 2, positive 2. So again, we want to multiply everything by 2, negative 2. So I can graph my original. Oops. So you have that little triangle there. And now multiplying everything by negative 2, here's my new D prime. E is going to be now 2, 0. And F is going to be 2, 2. So not only did my image get bigger, it was also rotated 180 degrees. All right, so those are some examples of the 4 different transformations to get you started on your homework. Have a great rest of the day. Bye.